Assalamu alaikum wa rahmatullahi wa barakatuh. This is Jafar from Duzi Academy. And today we have these videos to continue what we started in our workshop for bridging students. Inshallah, we'll continue the concepts. Like we'll take these concepts very quickly and then we'll start practicing because practicing is the main thing, is the most important thing. You have to practice. That's how everything will be clear, even the concepts. So we stopped something called if else, and else if. These are the conditional statements. These statements to determine a condition. If it's true, I'll do these things. If it's not, I'll do these things. So let's say, for example, if you are more than, your age is more than 18, then you can do blah 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 blah. If you're less than 18, you cannot do, but you can do blah 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 blah, or you cannot do at all. Okay, so this is the first thing we start about if. Okay, so to test everything, for example, if we have int x equals to 10, now we'll start to test this x. If x equals to 10, then print f hello, else printf by. So let's see, what is this example? I identify this variable x. I gave it value of 10. Then if x equals to 10, look how you test equality. You test equality by this samples. So you put equal equal. That means x equal to 10, not equals to 10. That means test if x equals to 10 or not, whether x equals to 10 or not. This is testing. But if I write like this, that means assign this 10, put this 10 inside the x. But in this way means test if x equals to 10 or not. So when you run your program, the program will start like this. X will be 10. So here, what your program will do is to put 10 equals to 10. So does 10 equals to 10? If yes, if it's true, then printf hello. If it's not, else you printf by. So you should figure out what. So we print hello. So let's put this as an x. So hello. So let's now change the value of x to this. Now we compile again. We start. We got by. Why by? Because when your program run, x will be 9. Does 9 equal to 10? No, doesn't. So this condition will be false. When this is false, your program immediately will delete this. This is nothing right now. Will go where? Your program will go to this statement. Okay, let's get this back. Okay, so this is about like simple conditional statement. All your conditional statements will be like this. You have to crack down your problem. You have to break down your problem. Any problem you face, you have to break it down into small pieces and go line by line. This is the way you have to start with, because if you want to be professional programmer, you have to understand how your computer thinks. And the only way to do this, at the beginning, you have to start with your compiler, line by line, like what I'm doing right here. Okay, x will be 9, for example. If the user put x as 9, so here the x will be what? 9. Then we'll compare 9 to 10. So, and we have like many logical samples, you know, most of them, like for example this, that means 10 greater than 9. If is 10 greater than 9? Yes, it is. It is true. So we'll get hello. If it's not, if for example we have here, we have 8. So is 8 greater than 9? Of course not. Then you'll get what? Bye. Bye. So for example, if we put here x instead. So when you run your program, x will be 9. 9. Is it greater? Is 8 greater than 9? No, of course. So you will get by. So, and we have like greater than, smaller than. We have smaller, all equal. This will be true. This condition will be true if we put here 9. 9. Okay. Is 9 greater than 8 or is 9 equal to 8? Either of the situation you will get it true. You will get this condition to be what? To be executed. So let's test. Is 9 greater than 8? Yes. So immediately print hello. So if we put here 8, is 8 greater than 8? No, it's not. Is 8 equals to 8? Yes, it is. So you will get what? Printf hello. So this is equal or greater. In either ways you will get true. So for example, if we only put like this, okay, is 8 greater than 8? No, it's not. So you will get what? You'll get this because you don't have equals. If you have equals, your program will check for greatness and for equality. Okay? So this is the main concept of if. If you have this condition right, okay, you'll get this. If not, your program will continue to else. Notice that you don't have to put else whenever you put if. You can eliminate this, okay? If you want to execute one condition by itself, and if this condition is not right, you will need to continue your program normally. So you will just put if and you'll get it right. So if we put here x, for example, so when our program runs here, x will be 9 again. 9 greater than 8, yes it is. So you will print what? You'll print hello. But for example, if the condition is not right, for example, if we put 7 here, and here we put printf, for example, my name, Jafar. Okay, so here when your program will run, x will be 7. Is 7 greater than 8? No, it's not. So this is false. And does x or does 7 equal to 8? No, it doesn't. So in either way, the condition is false. So this will not be executed. Your program will jump here. We'll finish this. We'll delete this because this is not true. This will be false or false statement. Okay. And your program will jump here and print if what? Jafar, only Jafar. But right now, if you put like this, if we put like this will not be executed. Sorry, before we do this, let's put this Jafar. Look now, I'll put here \n. So here false. Let's delete this and we put this as 8. Now 8 greater, no it's not greater, it equals, so this will get hello. Then we'll get what? Jafar, because your program will be continue. So hello Jafar. But if you put like this, else, okay, and you go here and press shift, okay, so you will not get Jafar this time because this statement will not be executed until this should be what? False. But this is not false this time. This is not false. 8 equals to 8. So we'll print hello. But do we need this time? No, we don't need else, because either this or this will be executed. If this is true, this will not be executed. If this is false, this will be executed. Okay? So hello, you get hello only, and you get what? \n. Don't forget, you have one line left. So let's start with our program. Our first program, I guess you have to enter two numbers and to check who's greater than who. Sorry, what is greater than what? Finding the maximum number between two integers. So for example, what you ask the user, okay, before each exercise I do, just stop the video and start to think of the problem by yourself and do your best, take like half an hour with an exercise. It's okay. Then pause the video, take half an hour, then you can continue, okay, to see your solution. Just try your best. Okay, so we need from the user to enter what? Two numbers. So we have int x and int, you can just write 1. Okay, so here cout, please enter your first number. Okay, and okay, sorry, what is cout? Oh my god, I'm writing C++. Sorry. Okay, print f. Okay. So print f, please enter your first number. Okay, so then scanf. Now you need to read the first what? The first number. So the first number is integer. You need what? To take, for example, x. Now you copy the same thing for the second number. You just change this second number, and here you have y. So now, right now we need to know who is greater than who. So is it x or y? How? We have to compare with if and else. So like in your normal language, when you analyze this problem, this is a little bit big ones, but if you want to analyze this program, what you'll say, okay, finding the maximum number between two integers. Okay, you'll say that means if x, or if the first variable is the greater one, I will print the first variable is the greater one. If the second one is the greater one, I'll print the second variable is the greater one. Look, in your normal language you used if the first number is the greater one. So here if. Now what is your first variable? Okay, by the way, you don't have to commit to my analyzing. You have to you can analyze your the problem by yourself, okay, by your thoughts. So if x, okay, greater than y, so this is the first situation. If x is greater than y, then x, printf, okay, the first number is the greatest one. Okay, /n, don't forget this /n. Okay, now if x is not greater than y, then y is greater than x. We'll see that we have like a special situation we'll handle later. So print f, the second number is the greatest one. Okay, so now let's try. Always after you finish your program as a beginner, try to trace your program, try to go line by line. So on the screen we will get what? Please enter your first number. Then the program will take the first number from us and put it in X. So for example, here you put an example for yourself to understand the problem, to understand your solution, to see if your solution is right. So for example, here you will put 6, and here the second one you'll put 7. So when you come here, you will put X as what? As 6, and this is as 7. Is 6 greater than 7? If 6 is greater than 7, then the first number is the greatest one. So is 6 really greater than 7? No. So immediately you'll go here and print the second number is the greatest one, which is correct because the second number is 7 and the first number is 7. Now try to do, here is 10 and here is 7, okay, and put 10 here. Okay, so what you'll get is 10. 10 is greater than 7, so you'll get printf. The first number is the greatest one, and you will not get this line. Okay, so let's try this. Okay. So your first number is 7, 10. So the first number is the greatest one, which is correct. Now try to put 6 and 8. So the second number is the greatest one, which is correct. Now we have another situation when x is equal to y. So how to handle this situation? Right now, if you put x as 7 and y as 7, for example, I put 7 here, 7 here. So is x greater than y? No. Else, so is 7, for example, here 7, 7. So what will happen here is your program will check, is 7 greater than 7? No. So will not print this line. Immediately your program will go to else. Since the first one is false, immediately your program will execute the second one because it's else. So you will get this one. Okay? So 7 and 7, the second number is the greatest one. But this is false, of course. This is like in your program, for your program, it's right. But for you, logically, it's not correct because 7 is not, it's not greater than 7. They are equal to each other. So in this case, we can have something like called multi-if or if else if. So else if we have this statement, this is new one. You can have as many conditions as you want. So for example, for this situation here, we have 3 situations. We have x can be greater than y, and y can be greater than x and y can be equal to each other. So here we have 3 situations. So right here, what we can do is, I deleted this one. Now we have something called if else if, okay, which is a special situation. Here another condition. See, if x greater than, we deleted, now we deleted what else, forget about else. This is more general or more useful than else. It's more accurate than else, because here in this condition, if this is false, it will immediately execute else, even if else is false logically, like we just saw. But this one will go and test condition by condition. So here we'll print what? We print this one. So here the second number, if y is greater than x, what we'll do, and then we can have another else if, is else if when, okay, here both are the same values, or both, okay. So here we'll start from the first one. 7. Okay, let's say that we have 7 and 7. 7 and 7. 7 is not equal. 7 is not greater than 7. Either 7 is not smaller than 7. So here you get this condition. So here you are checking for conditions, more than one conditions. Else if, is x greater than y? No. Is y greater than x? No. Is x are x and y equal? Yes. So both have the same values. Now, if one of these conditions is true, your program will go step by step. If one of these conditions is true, your program will ignore the rest of the conditions. So, for example, if you have here 8 and you have 7 here, here will be what? 8, and here will be 7. If 8 greater than 7, this is true. This is a true one. So your program will print the first number is the greatest one. You'll get this on your screen. Your program will not check for the rest of the conditions because they are related to the same condition. Okay, your program will not check for these conditions. Okay, and if you put 7 and 8, so get here 7 and 8. So now here will be 7 and 8. So is 7 greater than 8? No. So your program will skip this and go here. Is 8 greater than 7? Yes. So your program will print this and will ignore the rest of the conditions. If, for example, you have else here, else will consider as the end of this if. So for each if, you have main else, and you have many conditions between these. So this is the start, this is the beginning of the if statement, and this is the end. That's how your program knows that this is the beginning of this if. So these are conditions for the same situations. They are handled the same situations. We'll see with more examples, inshallah. So right now, our next program to find, don't worry about this if else, we'll get more exercises about it and you understand inshallah. C program to find maximum between 3 numbers. Now we have what? We have 3 numbers. So x, y, z. So your user will enter what? 3 numbers. Maybe it will enter 10, 11, 15 or something. But you don't know who's the greatest one. Okay? Let's go in here. I don't know why I deleted this. So here we put this. Here we delete this. Okay. Here we have to do another. Here we have the third one, the third number, and it will be Z. Okay, so let's discuss and let's analyze this problem by ourselves before we start the program. For example, if x was 10, Z was 9. Oh, sorry. Was 9, and Z is 15. Now we know that 15 is the greatest one, but how will you make your computer understand that this is the greatest one and print for you the greatest one is the third number, because this is the first number? So what you'll do, or what can you think about, is to start breaking your problem into smaller problems. So you'll start from x and y. You cannot at the beginning compare x and y. You have 2 situations. you have situation when x is greater than y or y is greater than x. Now forget about equality. X cannot be equal to y. So if right now, if your x greater than y, okay, or if your y is greater than x. So here we'll compare 10 and 9. Who's greater? X. Okay, so this one is true. So from here we'll get what? X. X is the greater one, right? Is the greatest one. Now, since we know that x is the greatest one, we don't need, now we finish with these things. We finish with x and y. We left with z. We don't know if z is the greatest one. But right here we know that x is greater than y. So for these things we know that x is the greatest one. Now for z, do we need to compare y with z and x with z? No, we don't, because we already know that x is greater than y. Since it's greater than y, so it is the only one that we need to compare with z, because if it is already the greatest one, then y should be, of course, should be what? Smaller than z. Okay, so for here we need what? We need to compare x with z. Okay, or we have z greater than x. So here we have what? Our x is 10 and our z is 15. Okay, who's the greatest one here? Of course, z. Okay, so we'll get z. So our greatest number is what? Is z. We'll get z as the greatest number. For example, if we have here 3, 10, 9, 3. So we are giving more examples so we understand the idea very clear. So we will compare 10 to 9, then we get what? X. X is the greatest one. Then we compare 10 to 3 because we don't need this, because this is already the smaller one. So here we'll compare, so we'll get again what? We'll get x, because 10 is greater than what? Than 3. So how to do this as a program? Okay, you will start compare as we just said, because you understand the idea. The only thing you need now, right now, to write the code. It's very easy. This is the easiest part. So if x is greater than y, then what? Then x, we know now it's the greatest. Okay, let's put this one here. Okay, this we'll need. Okay, so if if x greater than y, we'll start, as we said, we'll start with what? With two variables, with two first variables, or you can choose any two variables. So let's start. If x is greater than y, so that means what? X is greater than y, so we get x. Now what do we need to do now? To compare x with z. If that's the thing, look, printf, printf directed, okay, the first number is the greatest one. Okay, else, now, all right, then I'll explain. Here we have something wrong. Else, printf, the third one is the greatest. Okay, of course you have what? You have these things. Okay, so look now, if your x greater than y, so if you get 10 here, that means x is greater than y. That means we have x here. If this is true, that x is greater than, like this situation, if x is 10 and y is 10, then go and check if x is greater than z. Okay, here let's go to our example 15. If x is greater than z, that means what? That means what? X is the greatest one because it's greater than y. Here we checked if it's greater than y, and here we checked if it's greater than z. So the first one we entered is the greatest one. If not, if this else for this, notice that this else is for this. So if this is not right, we will go immediately. What does this mean? X is greater than z. Okay, if it's not right, that means z is greater than x. So you will get what? You will get z here, right? Because 10 with 9, we compared here, we get 10 is the greatest one. Then we compared x with z. Now we're comparing x with z. If x is the greatest one, you will get the first number is the greatest one. If not, that means z is the greatest one, greater than x and greater than y. Now we have another situation. This else is for this one. Okay, now we have another situation, else. Else for this means this else means that y is greater than x. This situation, because this is false, that means the true one what should be. Now if this is false, if x is not greater than y, that means what? Y is greater than x. Forget about equality. Don't. Now, what do we need to compare here? Since we know that y is greater than x, do we need to compare x with z? No. We need to compare what? Y with z, because it is the greatest one now. The greatest one, what? The greater one is y right now. So, if that's the situation, what we'll get the second number, second number is the greatest one, else the third number is the greatest one. So look at this situation. This is new. So for example, if you have here 11, so for instance, you will go for the first condition. Okay, let's make this. Okay. Okay. So let's test this. X will be 10 and y will be 11, z will be 15. Let's go with our program line by line. So x will be 10 and y will be 11. So is 10 greater than 11? No. So immediately this condition will what? The whole condition, this will be ignored because all of this for one condition. So the whole statement will be what? Will be ignored. You will go to what? To else immediately. So now you know that y is the greatest one. You will go here and compare for what? Now you compare for y because it's the greatest one. You'll put here. Okay. Is y greater than z? 11 and 15. Is 11 greater than 15? No. So immediately you'll get what? 15 is the greatest one. If this was 20 or 21, you'll get what? This condition to be true. Okay? So this, I guess, it's like a bit complicated, but it's okay since you understand the idea. Okay? The main thing you have to understand, and then you have to apply by yourself. Okay. So let's move to another question. This is easy. C program to check whether a number is positive, negative, or 0. So to check for a number, this program will check for a number. That means you need only one number from the user. So printf what, please enter the number. Okay. Oh, why didn't we try our, okay, this one is important. Okay, we have here, because we have to delete this, as you know. This is make nothing. Okay, so your first number is 12 and 10 and 24. Of course, the greatest one is 24, so your program should print for you the third one is the greatest one. So the third one is the greatest one. You can check again. For example, you have 10, you have 3, 2, and you have 3. So the first one is the greatest one, which is 2. Okay. Now let's move to our new program to check whether a number is greater than 0, like positive or negative, or what, or equal to 0. So here we have to printf, please enter your number. Here scanf, of course, if you want to read, we read like this, x. Now we have to test for this number. How to know if a number is positive or no, or not? How? A number is positive if it's greater than 0. Okay? A number is negative if it's smaller than 0. A number is equal to 0 when it's equal to 0. That means the number is 0. So you need to test these conditions in if. If this, if this, if this. If this is true, then it's 0. If this is true, then it's negative. If this is true, then it's positive. So quite easy. So x, for example, the first one, x is greater than 0. That means printf the number is positive. Okay. What the heck? Okay. So now you have 3 conditions. So you can put what? Else if, since there are 3 conditions. You know, usually it's better to use else if instead of else, unless you have something unpredictable. You cannot predict what you'll get. So else if, you'll get what? X is what? Greater, smaller than 0, then printf what? The number is if. Oh, I guess negative. Oh, whoa. What did I do? Okay. So right here, if we think of our number, we have only 3 situations. It can be greater than 0, or smaller than 0, or equals to 0. In your real life, you don't have other choice. You don't have other choice. A number can be either 0 or greater or smaller than 0. These are the 3 choices you have. So here you can either, look, you can either write else if x is equal, test if it's equal to 0, and you write print if your number is 0. Okay, you can do like this. But if you only left with this situation, because you already handled what the 2 situations, and you already have 1 situation left, you can easily put else. So if this is not true and this is not true, logically the true one is your number is 0, because it's not greater than 0, it's not either smaller than 0, so it should be 0 itself. Okay, so you can either put else or you can put like this. Okay, so let's say that we enter 5 greater than 0, so print if the number is positive, and all of these will be skipped or ignored by the compiler because this is the true one. And if we have -8, this will be true, and this will be what? We will check for this is false, and we'll check for this. If it's true, it will print negative and ignore the rest. If this is false, because for example, I entered 0, so I'll get this is false, I'll check and put false, false, and go here and put it is 0. So for example, 10 is positive. Okay, -1 is negative, and 0 is 0. Okay, but for example, if we put here else, notice that else is different from else if. Else if you need to specify a condition, but in else you just else takes all the things when if is false. Okay, so for example, if you eliminate this thing, for instance, if a number was positive, you'll get positive. If the number is 0, you will get 0. If the number is negative, you will get the number is 0. Because when negative, if you have -5, is it greater than 0? No, no. So go immediately here to else and execute else. So if you put -1, your number is 0 because it doesn't understand. But if you put in here else if x equals to 0, look now what will happen. If you put -1, there is nothing, because you don't have such a situation when you handle -1, because here you will go here, -1, is it greater than 0? No. Is x equal to 0? No. Then we don't have any else or any other situation to handle. If you have else here, you'll get what is inside else, but you don't have even else. So I hope you understand this thing. Let's move to our next question. Okay, so we need to know if a number is divisible by 5 and 11. This is not true. Here I guess you have to take 5 and 10, because there's no such a number that is divisible by 5 and 11 at the same time. Okay, so if, for example, oh sorry, I get confused. No, yes. Okay, so for here, yes, I guess this is right. 11 and 5, yeah. So how to test the divisibility of a number in your programming language? This is like something to think about. Okay, if you want, you can pause the video and you can think about using this operator. Okay, what do we mean by divisible number? If x is divisible by y, if 10 is divisible by 5, that means if we divide 10 on 5, we will get 2 and no remainder. Remainder will be what? Your remainder will be 0. But for example, if you divide on 4, your answer will be 2, but the remainder will be 2, because you need another 2 to get to 10, because 2 multiplied by 4 multiplied by 2 is 8, and you need 2 remainders to the 10. Okay, so here the concept of divisible or divisibility you need to have no remainder. If 10 is divisible on 5, that means 5 can divide 10 with no remainder, with remainder 0. How to test the remainder in our programming languages? Using this operator. So 10 modulus 5 will get 0. Okay, 10 modulus 4, that means what is the remainder? That means calculate the remainder. Okay, so here you get 2. For example, 15 on 11, there's 1 11 and you have 4 remainder. So the concept of divisibility depends heavily on what? On the modularity, the remainder. If you have a remainder rather than 0, that means it's not divisible. This is not divisible. 10 is not divisible on 4 because you have remainder 2. 15 is not divisible on 11 because you have 4 as a remainder. You need to have a remainder as a 0. So how to check if a number is divisible on 5 and 10? Okay, for example, here you have your number. This number, it will be taken from the user. Please enter your number. Okay, scan if what d, and here, right here, you get what? X. Now we have to check. Let's first check on 5. Only on 5. We need to know if a number is divisible by 5 or not. So we'll say that x 5 equals to what? To 0. Let's understand what does this condition means. Okay, first we'll start from here. When we have, look, remember when we put this, the first condition we put as this. Okay, we will check this side with this side. If x is 10, if the user enters x as 10, you will put here 10. Then check this side with this side if they are equal. If this is, for example, 5, we'll check this side with this side. Now, the same thing happens with what? With this. First, we will check for this, we will finish with this side because this is a little bit complicated. This is a formula. You have to have the result. You have to have the result of this formula. Then you compare the result with this thing because you have to compare both sides. So here x will be taking the remainder of the division operation of 5. So if your x is 10, for example, imagine if your x is 10, x 10, what is the remainder of 10 divided on what? On 5? 0. So here, this is your answer. This is the answer of this formula. So here, this will be erased and put 0 here. So it will compare. 0 is equal to 0. That means this is divisible on 5. This is divisible on what? On 5. If it's 11, you got what? You get a remainder of 1. We explained the concept of remainder in our class. Okay? So here, if we put here 11, here the number, what will be the result of x modulus 5 will be 1. Okay, is 1 equals to 0? No, it doesn't. If we put 12, here will be what? 2. If we put, here we will get 3. Okay, so all of these things are not equal. So if we put here 14, you will get what? 4. Still not equal. If you put 15, now 15, that means when I divide 15 on 5, you will get what? 0. That means 0 equals to 0, so you'll get what? It is divisible. So returning back to our what? Oh, wow, nice. So first you will divide, you will take the remainder of, how to test if a number is divisible by 5? You have to divide it on 5 and see the remainder. So here we divide on 5 and see the remainder. If it's equal to 0, that means it's divisible by 5. If it's not, that means it's not divisible by 5. So printf, it is, okay, it is, I don't know, divisible like this? I don't think so. Oh, yes, divisible. Okay, yahoo. Still not the same. Okay, so else if the remainder is not equal to 0, that means it's not divisible. It's not divisible by 5, of course, by 5. Now we are handling only the first condition, which is divisible by 5. We have 11. Now we have to check for both 5 and 11. The same way, if we want to check for 11, we have to divide on what? You have to take the modulus of what? Of 11, and it should be 0. So here in your if, you have something called AND. In AND, this is the first condition. You can put more than one condition, okay, in the same, for the same if statement. For the same if statement, you put here AND, or you can put like this, AND. You can put both. So here we have another condition. Okay, we will explain, don't worry. Just give yourself, now here we have it. Now, if x is divisible, if we divide x by 5 and the remainder was 0, okay, you will get what? It's divisible by 5. For example, let's take this number. Let's suppose that x is equals to what? 15. Okay, now let's start with the first condition. By 5, what is it? 0. The remainder is 0. But let's do modulus 11. Okay, of course the remainder is not 0, it is 4. So this is right, but this is not right. So the whole condition, you have, if you want to execute this statement, this have to be right and this have to be right, because it is AND. You need to check if it is divisible by 5 and 11. And 11, both. It should be divisible by 5 and 11. But in this situation, it's divisible by 5, but not by 11. So you will get what? Not divisible. Because we are checking for what? You'll get what? It's not divisible, because this will be the entire condition will be false. So you have to check for both. Okay. What if the user enters this 55? So let's check. X modulus 5, you will get 0 because it's divisible by 5. Here x divisible, you will get 0 too, because it's 55. Any duplicated number, you divide by 11, it's 0. The remainder is 0. So here you will check, you will get here true, because 0 will be 0 equals to 0, and here will be 0 equals to 0, so you will get this one. Print it, it's divisible. Okay, but if one of these conditions was not right, this will not be executed, this will be executed. You have another operator which is OR. You can write it this way or this way. But of course, these symbols are the like the most common one. You have this. In the situation OR, you can write it like this. or like this, or one of the condition has to be right so you can execute this phrase. So if you, let's go back to our this, here you will get 0 and here you will get 4. So x modulus 5 equals to 0. Yes, this is true, this is true, but this is false. You will get this because you need one of them. It is either divided by 5 or it's either divided by 11. One of them is enough, but if both of them are not right, so here you or either this or this. If this is right, maybe you have this right. For example, if you have here 77, this is not right, okay, because here you'll get 1, remainder of 1, okay, and here you'll get 0. Here it will check for this, this is not true, but this is true. You will get printf, it's divisible, because it is divisible by one of them. You need or, not and, not both of them, one of them, okay. For example, if you put here this, here you'll get 2, remainder as 2, and here you get 1. So this is not true and this is not true. This will not be executed. This will be executed, okay, because both are not true. In or, one of these have to be right. In and both of these have to be right, okay. Okay, so if we want to, sorry, we have to delete this to check for our allow. So let's try with this. Yes, for C++, I was talking for C++. You have to put these samples, okay? Not and, don't use and or for the C. Okay, for C++ you can, but for C you cannot. You have to use the samples. So you'll get what? For example, let's test 15. Okay, 15 is divisible by this, but not divisible by this. But you need both to be divisible by both because you have and here. So this is false because one of them is not divisible. So you'll get this. Okay, it's not divisible. So if you put 55, it's divisible by both. So you'll get it is divisible. Okay. Okay. The next question, how many questions? Oh, that's nice. Okay. For the next questions, check whether a number is even or odd. This is quite easy if you understand exactly the same idea. If we want to know if x is odd or even, even means it is divisible by 2. That means the remainder of x divide 2 should be 0. If it is 0, that means it's even. If it's not, then if it's not, okay. By the way, if you want to test if it's not equal, we'll see right now. That means it's odd. Okay. This is quite easy. Let's do, and I'll show you something like not equal. Okay, if x equals, okay, sorry, x 0, then what does it mean? Printf, this is even number. Okay, else, of course, else, in your numbers you have two situations. Either a number is even or odd. You have no other situation except if you want to discuss about the 0 in mathematics. Mathematicians talk about this number. It's not even, either odd or even, but we don't we don't care about this thing. Okay, let's suppose that we have only even and odd numbers. Okay, else you'll get what? Print if it is odd. Okay, so if you get 0, the remainder as 0, when you divide on 2, that means it's absolutely even number. If you get rather than 0, it's absolutely an odd number. So if you put like this, okay, of course it's odd. If you put like this, it's even. So here, if we want to put like else, if we want to put a condition for the odd number, that means for the odd number, if you want to test if, for example, we have the problem upside down, we have to check first for the odd. Let's suppose that you want to check if it's odd. That means the remainder of x divided by 2, that means should be what? Should not be equal to 0. It can be any number rather than 0. So you put here this thing, odd. And here would be what? It's even. Let's see what we do. We'll check for x divided by 2. For example, if you have 21. Okay, 21 divided on 2, the remainder will be what? Will be 1. Will be 1. So here you are checking for the non-quality. Okay, so you'll put here 1. Okay, that means 1 is not equal to 0. Is it true that 1 is not equal to 0? Of course it's true. So you will get what? This is odd number, because here you get something that is not equal to 0. If it's even, you have to have something equals to 0. But since you put this sign, that means test if the first side not equal to the second side. If it's not equal, that means this condition, it's true. If it is equal, that means this condition is false. Okay, so this is the opposite of equal. So, for example, let's take an example here. This is true or false? This is true or false? Of course, true, because 1 is not equal to 0. That means 1 is not equal to 0. So this, what about this? 0. This is false. This is false. What kind of false is this? Okay, this is false because 0 is equal to 0. If we put like this, okay, this is true because 0 is equal to 0. Okay, so here, whether you put like this, x, it is what? Even. Here, it is odd. Oh, yes, we can add another, like here, for the odd number, we can put what? The condition should not be equal to 0. Should not be equal to 0. If we put 12, okay. If we put 13, it's odd. This is okay. Okay. Let's move to another. This one needs the ASCII code. Okay, the ASCII code you have to think about. Okay, we'll return back to this question. With the ASCII code, you have to about the ASCII code. Oh, okay, I'll do one lecture about this later. One video about this. The ASCII code I have to explain, because you can convert your character. There is a relationship between your character, each character in your look. This is character. This is character. This is character. Each character is represented in your computer as a number. Okay, as a number. So this ASCII code will convert your your characters to numbers, or your numbers to characters. Okay, let's check for this question. You need to check whether a character that is inserted by a user, whether it's vowel or constant. Okay, how to do this? Okay, for example, let's suppose that we have character in here. Okay, see. A user will enter a character. This character can be whatever any like any letter from A to Z, or from what, A capital to Z capital, because in our language, normal language, we don't have, like when we speak, we don't have this difference, but in the computer you have this difference. We have difference between A small and A capital. So you have this range. A user can enter from A to Z any value, A, B, C, D, E, F, G, H, I, J, K, and here the user can be A, B, C, D. We need to check for this value if it is vowel or constant. Okay, so first of all, we have to check, because the minimum set of these characters will be the vowels. What are the vowels we have? E, I, U, O, right? 1, 2, 3, 4, 5. These are the vowels you have in the English letters. So, if C, a character C, is one of these, equals to one of these 5 characters, then you print this character is vowel. If it's not equal to either one of these, you print what? It's a constant. So quite easy. Let's start if C, now C. Okay. When do we print this is vowel? When C is one of these, either one of these. Look and listen what I'm saying. Either one of these. So C can be this or this or this or this or this. Then you print what? Vowel. So you will use or. So immediately, C, is it equal to A? Or immediately use this. Or C, is it equal to E? Or C, your character you took by from the user, is it equal? Now character C, this is a little bit confused. A character, that means a variable named C, not the letter C. Okay, so I'll put something here, for example, letter. Okay, this is our variable. This will have the letter from the user. Okay, letter. So is this letter equals to I, or letter equals like this? You have to write like this, huh? Or sorry, or oh my god, or letter equals to O. If that's the situation, then printf your letter is a vowel. Okay, and else, if it's not one of these, not this, not this, not this, not this, not this, because this is OR. If one of them is true, then you will print what? Vowel. If none of them is true, not O, not U, not I, not E, not A, you don't need to mention the whole letters like the B, C, D, and F and G, because we have these letters left, the rest of the letters left here. You don't have to mention all of these letters. Else, immediately else, if no one of these letters equals to letter, then else it's a constant. Okay, printf. Okay, immediately. So here we print f. Please enter character. Okay, here we give the user a hint from A to Z, or from A to Z. Okay, and then scan F. Here we have character. We have to, what is the name of the variable? Letter. Okay, so let's start with this. Okay, For example, if I enter, okay, it's val. If we put b, it's constant. Quite easy if it's eval. Okay, so your program will test if you enter O, for example. Okay, letter equals to O, no. Equals letter equals to E, no, 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 yes. Then print it's a vowel. For example, if I put B, is it B? No. Is it B? No. Is it B? No. Is it B? Is it B? No. This is not. These are not B. So immediately we'll go to this one because here we have or. Imagine if we have what? If we have and instead of these things. So all these conditions have to be right. So the letter have to be A and E and I and U and O at the same time, which is logically cannot be true in any situation. So this was about if and else. I guess if you go and find and at the first you apply these, you have the questions. If you solve these questions by yourself, it will be great. Then you go and find further exercises to do by yourself and practice and ask and post any questions or any problem you face. That's the only way you can be a real programmer. Since I could learn it, my friend could learn it, you can learn it like the way if one of us as a human can learn something, that means the rest of us can learn. There is no skill you cannot learn. Okay, just believe in this. You are just sometimes you are being lazy to learn new stuff. So just make your effort, go and find further exercises. Just like put an hour a day for the exercises. Okay. Okay, that was Jafar with you from Doozy Academy. Thanks for listening. I know, oh my god, it has been like an hour. Okay, thanks for listening to my boring lecture. Okay, to my boring video. See you next time, inshallah. Thank you.